Every time you send a message, open a website, stream a video, or buy something online, your device is taking part in one of the largest systems humans have ever built. The Internet is not one giant computer, and it is not a single service owned by one company. It is a global system of interconnected computer networks. A home Wi-Fi network, a university network, a mobile phone carrier, a cloud data center, a government network, and a business network can all connect into this larger structure. That is why the Internet is often called a network of networks. Its real power comes from allowing very different devices and networks to communicate using shared rules. At the center of this shared communication is the Internet Protocol Suite, commonly called TCP/IP. A protocol is simply an agreed way of doing something. In everyday life, traffic lights are a protocol for roads, and postal addresses are a protocol for delivering mail. On the Internet, protocols define how data is formatted, addressed, transmitted, routed, and received. TCP helps manage reliable delivery, making sure information can be broken into pieces and reassembled correctly. IP handles addressing and routing, helping those pieces travel from one network to another. Without shared protocols, networks would remain isolated islands, unable to understand one another. A key idea behind the Internet is packet switching. Instead of sending one continuous stream through a dedicated line, data is divided into small chunks called packets. Each packet carries information about where it came from and where it needs to go. These packets can travel across different routes through routers and networks, depending on what paths are available. When they arrive, they are reassembled into the original message, web page, file, or video stream. This approach made networks more flexible and resilient than older communication systems, because traffic could adapt if part of the network became busy or unavailable. The Internet includes many kinds of networks, linked by electronic, wireless, and optical technologies. Inside a building, data may move through Ethernet cables or Wi-Fi. Across cities and continents, it often travels through fiber optic cables carrying pulses of light. Mobile devices connect through cellular towers, which then link into larger provider networks. Under oceans, massive submarine cables carry data between continents. To the user, opening an app feels instant and simple. Behind the scenes, the request may cross local equipment, an internet service provider, backbone networks, exchange points, and data centers before a response returns to the screen. One important distinction is that the Internet and the World Wide Web are not the same thing. The Internet is the underlying global network infrastructure. The web is one major service that runs on top of it. Web pages, links, browsers, search engines, and web applications belong to the World Wide Web. When you type a website address or click a link, your browser uses Internet connections and web protocols to fetch documents and applications from servers. The web became so popular that many people use the words interchangeably, but the Internet also carries email, voice calls, file transfers, gaming traffic, streaming media, and many other services. The Internet transformed older communication media by turning information into digital data that could move quickly across networks. Paper mail gained a digital counterpart in email. Newspapers and print publishing were reshaped by digital editions, news websites, and aggregators. Radio and television were changed by audio and video streaming. Telephone calls became possible through Internet telephony and voice over IP. These changes did not simply move old formats onto screens. They changed timing, distribution, and participation. A message could be sent globally in seconds. A video could be watched on demand. A single person could publish information to audiences once reachable only by large media organizations. Personal interaction also changed dramatically. Instant messaging made conversations faster and more continuous than email. Internet forums gave people places to gather around shared interests, technical questions, hobbies, or communities. Social networking services added profiles, feeds, sharing, and large-scale public conversation. These services depend on the Internet's ability to connect many devices through common protocols, but their impact is social as much as technical. They changed how people maintain friendships, discover news, organize events, build communities, and express identity. The same network that can deliver a scientific paper can also carry a birthday message, a live stream, or a global debate. Commerce is another area where the internet became deeply embedded. Online shopping allowed businesses to reach customers far beyond a physical storefront. A small seller could list products for national or international buyers, while large retailers could combine warehouses, websites, apps, and delivery systems into one operation. Business-to-business services also moved online, affecting supply chains across entire industries. Orders, invoices, payments, inventory updates, shipping data, and financial services can all flow through networked systems. This means the internet is not only a communication tool for individuals, it is also infrastructure for modern markets, logistics, banking, advertising, and customer service. The origins of the internet reach back to research into sharing computer resources and improving data communication. Early computers were expensive, limited, and often used by many people through time-sharing systems. Researchers wanted ways for computers to communicate efficiently, even across distance. Packet switching became one of the key breakthroughs. In the 1970s, research and development commissioned by the Defense Advanced Research Projects Agency, or DARPA, helped develop internetworking protocols. Universities and researchers in the United States, the United Kingdom, and France contributed important ideas. The internet did not appear all at once. It grew from decades of experiments, standards, and collaboration. One of the most unusual things about the internet is that it has no single central owner or global command center. No one organization controls every cable, router, server, access policy, and application. Instead, the internet works because many independent networks agree to interconnect and follow compatible technical standards. Each network can set its own policies for access, pricing, security, and usage. An internet service provider, a university, a corporation, or a government agency may manage its own network differently. Yet if they use the shared protocols and connect through agreed arrangements, they can participate in the broader internet. Even without a single ruler, the internet still needs coordination. Two of the most important shared systems are IP addresses and the Domain Name System, or DNS. An IP address identifies a device or service location on the network, much like an address helps route physical mail. DNS translates human-friendly domain names into the numerical addresses computers use. When you enter a domain name, DNS helps your device find where to send the request. The global coordination of these name and address spaces is directed by ICANN, the Internet Corporation for Assigned Names and Numbers. This coordination helps prevent confusion and keeps the global system usable. Technical standards are another foundation of the Internet. The Internet Engineering Task Force, or IETF, develops and standardizes many of the core protocols that make Internet working possible. Its work is important because the Internet depends on interoperability. Equipment, software, and networks from different organizations must be able to work together. A phone made by one company can connect to a router made by another, reach a server in a different country, and display content built with yet another set of tools. That cooperation is not automatic. It requires documented standards, public discussion, testing, and adoption across the global technical community. So the Internet is best understood as both technology and agreement. Technically, it is a vast collection of networks, cables, wireless links, routers, servers, addresses, packets, and protocols. Socially and economically, it is the foundation for communication, media, business, education, entertainment, and public life. Its strength comes from being decentralized but coordinated, open enough for new services to grow, and standardized enough for billions of devices to communicate. When a page loads or a message arrives, it can feel effortless. But behind that simple moment is a global network of networks, built on shared rules and constant cooperation. If you found this helpful, please like this video and subscribe for more explainers.